Innovative building techniques are now being promoted in communities all around Washington state to help protect water quality, reduce contributions to climate change, and conserve valuable natural resources. This program will highlight ways new construction techniques can be implemented to reduce the negative impacts of stormwater runoff. Every year, Bellingham receives, on average, 36 inches of precipitation. Most of it falls as rain, but some falls as snow. During the wettest periods of the year, anywhere from 500,000 to several million salmon find their way into rain-swollen creeks and streams right here within the city's limits. Bellingham streams, along with every other stream and creek in Whatcom County, receive rain runoff directly from land in their watersheds. The quality of the water that fills these salmon-bearing streams is directly affected by the health of the watershed surrounding them, and since every waterway eventually leads into Bellingham Bay, the quality of the water in the bay is also affected by these waterways. Many of eastern Whatcom County's numerous watersheds are forested in mountainous landscapes that are generally unsuited to dense human population. Normally, as rain falls on these remote tracts of land, the forest and undergrowth slow down the percolation of water into the ground and gradually release runoff into the area's streams. Typically, this natural process results in clean flowing streams in these far eastern regions of Whatcom County. Further west, the terrain begins to level out. The land here is better suited to human development. Large forested tracts give way to roads, farms, and eventually the population centers of Whatcom County. Some 95% of Whatcom County's population of about 200,000 folks reside here in the western portion of Whatcom County. About 75,000 people live within the city of Bellingham. Rain that falls in the Bellingham urban landscape rapidly spills off roofs, down our drains, across our lawns, onto driveways and streets, becoming stormwater. Our urban landscape has far more hard, impervious surfaces than the natural forests which our urban landscape has replaced. Impervious surfaces like concrete and asphalt trap water on the top and don't allow water to percolate slowly through the soil. Instead, the water collects on these hard surfaces, moving downhill quickly. And many of these surfaces collect residue from motor vehicles, chemicals from gardening and lawn maintenance, pet waste, and other contaminants that can be lethal to fish and marine life. Most of this urban runoff heads to the nearest storm drain, directing it to a nearby stream or straight into Bellingham Bay, carrying all the pollutants with it. And this is very different from the generally slower flow and ground filtering of rainwater in forested areas. Ultimately, everything in our urban neighborhoods, from trash to toxic chemicals, can find its way into our streams and then into Puget Sound. Pollution in Bellingham Bay can and has produced a greatly compromised environment for marine life, from oysters to crab to salmon to whales. Some of this marine life the world depends on for food. Other marine animals are threatened or endangered. We must protect them. The Washington State Department of Ecology and Bellingham's own municipal code regulate how we must control stormwater and manage pollutants so we can prevent costly urban flooding and enhance our streams and Puget Sound. In the end, if we cannot control both the quality and the quantity of the stormwater entering Puget Sound, we will be forced to treat it. Stormwater treatment can be a very expensive process. It's much cheaper to decrease the level of pollutants and control the amount of runoff before it becomes stormwater, before it enters our streams, and before it enters Puget Sound. One of the ways this can be accomplished is in urban building design. The days are past when we can simply erect a building with our only concern about stormwater being how quickly to move it off the roof and into the street. Recently, the city of Bellingham managed the design and construction of a new 41,000 square foot museum building. Its main architectural feature is a tall, curved glass wall that will radiate light into its courtyard. The structure has become known as the Lightcatcher building. The building is designed to LEED Silver standards as determined by the U.S. Green Building Council. LEED stands for Leadership in Energy and Environmental Design. With the Lightcatcher building, these elements include a green roof, rain gardens, an efficient rainwater collection system, and a permeable concrete loading dock. Now, all these systems contribute greatly to the city's intent to reduce stormwater flow into Puget Sound. The most visible stormwater feature of the building is here on its green roof. In North America, the benefits of green roof technologies are often poorly understood and implementation remains pretty slow. In Europe, however, green roof technology is a broadly accepted construction practice. Green roofs provide a mechanism that helps regulate both the quality and the quantity of stormwater that leaves the building site and enters the municipal system. A properly engineered and installed green roof is more than just a garden of plants on the roof. And an efficient green roof can conserve energy, extend the life of a roof, and help to advance urban air quality as well as improve stormwater runoff. So, what exactly is a green roof? Typically, a green roof system is an engineered soil mixture and associated plantings that work together to absorb and retain rainfall. These systems are very site-specific and engineered to meet particular climate requirements. In Bellingham, if we collected all the water on this roof over the period of 1 year, we would have water about 3 feet deep over the entire roof. A 30-foot by 30-foot roof would generate over 20,000 gallons of stormwater that would normally run off the roof and into the storm drains and into Bellingham Bay. We get most of this rainfall in the winter months, and plants can be subjected to freezing and marine storms. In summer, we can receive less than an inch of rainfall some months. Now, all these factors have to be taken into account as a green roof is designed to meet the specific climate needs of a geographic locality. A green roof engineered for the climate in Detroit will not function effectively in Phoenix or in Bellingham. The green roof for the Lightcatcher building was designed and prefabricated at a company that specializes in green roof engineering. The completed modular elements were transported to Bellingham, ready for placement on the roof. The mixture of soil and plants are placed in pans about 5 inches deep and sized to be handled easily. This allows for simple manual installation and quick removal if roof repairs are needed. The soil or growing medium is designed to support the specific plants chosen for this roof and also to work the best under the climate and moisture conditions for Bellingham, Washington. The plants on this roof are from a family of sedums and grasses that are known to be able to thrive in both our high winter rainfall and our low summer rainfall. These plants can also sustain freezing as well as temperatures exceeding 100 degrees Fahrenheit. The sedums store water in their fleshy leaves in winter and use that water through the summer when rainfall is scarce. This simple system can eliminate up to 50% of the stormwater runoff typically generated by conventional roofs. Additionally, the green roof acts as a thick layer of insulation, making the building more efficient to heat and cool, therefore contributing to resource conservation. The plants also absorb carbon dioxide and improve air quality by helping to reduce greenhouse gases that contribute to climate change. All of these factors contribute to the City of Bellingham's climate protection program. But the green roof is only one system implemented in the design of the Lightcatcher building to stem the flow of dirty stormwater into Puget Sound. Around back at the shipping dock, the parking surface here is at the lowest grade of the building. Typically, this concrete surface would be fitted with a drain to remove stormwater that collects here and move it into the city's storm drain system. Instead, engineering requirements here called for a permeable concrete surface that would allow water to pass through it to the ground below, where it can be filtered by gravel and earth and slowly and naturally move toward Puget Sound. Another feature outside the buildings are several rain gardens. A rain garden is a planted depression that allows rainwater runoff from impervious surfaces like roofs, driveways, and walkways, and compacted lawn areas the opportunity to be absorbed. These rain gardens reduce rain runoff by allowing stormwater to soak into the ground. Rain gardens can cut down on the amount of pollution reaching creeks, streams, and Puget Sound by up to 30%. Lastly, not all of the roof surface is a planted green roof. Part of the building's roof is a typical membrane roof structure. Water that falls here is removed by several conventional drains, but instead of the drains leading to the city's stormwater system, these drains take the runoff to large water storage tanks or reservoirs at the back of the building. Here, the water is stored until used, and where it gets used is in the building's toilets. Instead of using costly municipally processed water like our drinking water to flush toilets, this building uses diverted and captured stormwater at 1.5 gallons per flush, and on average some 100 flushes per day. This will save at least 26,000 gallons of expensive treated water annually. Together, these engineered building systems add considerably to both the conservation goals and stormwater runoff requirements of the city and the state, and significantly decrease stormwater runoff, the cost of heating and cooling the building, and the unnecessary use of expensive municipally treated water. Now, whether you're building a house, a commercial building, office complex, or multifamily unit, the City of Bellingham wants you to consider how green technology and LEED standards fit into your project. For more information, contact the Permit Center of the Bellingham Building Services Division at 778-8300 or the city's website at www.cob.org and search for Green Development.